We're going to continue on with factoring with special cases with certain binomials, and a binomial is two terms. So the first one we're going to look at is a difference of squares, which is what you want to do when you have two perfect squares subtracted. Now, I use this example specifically because these are not perfect squares, but you have to remember you always have to look for a greatest common factor first. So if I look at these two terms, the thing they both have in common is a 2, so I have to first take that out before I do anything else. And now you can see that these right here, this is a difference of squares because x squared is a perfect square, 25 is a perfect square, and difference means subtraction, so there's a subtraction sign in between. So now I can factor this out using the difference of squares method. So I'll keep the 2 out front when I factor. And so what you do when you do difference of squares is you take the square root of the first term, so what 2 of the same thing multiplied to x squared, which would be x, and you put that in the first spot. You take the square root of the second term, so what 2 numbers multiply to 25, the same 2 numbers, which would be 5 and 5, and you put that in the second slot, and then you always just put a plus and a minus. And again, if I multiplied all this back out to check my work, I would get what I started with. The next thing with binomials is something called the sum or difference of cubes. So that's when you have 2 perfect cubes, and again, a cube is when you have 3 of the same things multiplied together. Now we're going to use this acronym of SOAP, and I'll explain that once we get to it. So what we want to do is you want to look at these terms and find what the cube root of each of them is. So for this first term, x to the third, what 3 of the same thing multiply to get that? That would just be x. And then we're going to do the same thing with 27. So what number multiplies 3 times together to get 27? That would be 3. All right, and then what you do with these terms right here, I make this little m, is you square the first term, so that would be x squared. You multiply, and we kind of made like an m to remind you, so you multiply x times 3, that would be 3x. And then you square the last, and that would be 9. So you're going to have 2 sets of parentheses. So the first set is going to be what we had on top here, so I'm just going to right up here, x plus 3. And the second set is what we have on bottom, and I'm specifically leaving spaces. And so the last thing to fill out the signs is to remember SOAP. So what this is you look at your original problem, and when I do this part, from here on down, I don't worry about signs until the very end, which is why I left spaces. So SOAP will help you always remember what type of signs to use for this type of factoring. So the S in SOAP stands for same. So same means the first blank is the same sign we started with. Because we started with a plus, that means this will be a plus because we keep the same sign. O is for opposite, so that's the opposite of what we started with. So we started with a plus, the opposite of a plus would be a minus. And then your last blank is AP for always positive, and so that would be the last blank. And then this whole thing right here would be your answer for factoring this problem. And so even if this was a minus here, you would still use SOAP. If this was a minus, the first sign would be a minus, because that's the same. The second sign would be a plus, because you change it. And the last sign would always be positive. So you can use SOAP whether this is plus or minus, as long as you remember that.